When you look up at the night sky, what you're actually seeing, it's less than 5% of what's really out there. I mean, the vast majority of our universe, the stuff that's actually holding galaxies together and basically deciding the fate of the cosmos, it's completely invisible. Today, we are going on the hunt for the biggest piece of that whole cosmic mystery.
Okay, let's just dive right in. This chart, it lays it all out. Everything we know and can see, stars, planets, you, me, all of it, is in that tiny little sliver of normal matter. The rest, about 95% of the universe, is made of two things we really don't get. Dark energy, which is this force pushing everything apart, and our main target for today, dark matter, which is the invisible glue holding it all together.
It's kind of humbling when you think about it, isn't it? Everything humanity has ever seen is just the froth on top of this huge, dark cosmic ocean. And our mission here is to go deep and investigate the biggest, most mysterious part of that invisible iceberg. To really start our investigation, we've got to go back to the scene of the crime. See, the central problem is this. When astronomers look at how galaxies are spinning and how they clump together in these huge clusters, the gravity just doesn't add up. There has to be something massive out there that we just can't see.
So, what are we even looking for? Well, here's the official profile of our invisible culprit. Dark matter is, well, it's dark. It doesn't give off light, it doesn't block light, it doesn't reflect light. The only reason we know it's there is because it has mass, and that means it has gravity.
Every great detective story starts with those first few clues, right? Those little inconsistencies that just tell you something is wrong. Well, for dark matter, those clues started popping up almost 100 years ago, and they were written in the way the stars move.
The case file really opened back in the 1930s with an astronomer named Fritz Zwicky. But the evidence that made everyone say, whoa, okay, this is real, came in the 1970s, thanks to the incredible work of Vera Rubin. So let's take a look at what they actually found.
Zwicky was looking at the Coma Cluster, this enormous collection of galaxies, and he measured how fast they were all moving and realized they were just whipping around so fast that the cluster should have just flown apart ages ago. The gravity from all the stars he could see just wasn't nearly strong enough to hold them. He knew right then that there had to be a huge amount of unseen dunkle materia, his term for dark matter.
And this is where the mystery really gets weird. Decades later, Vera Rubin was studying how individual spiral galaxies rotate. Now, think about a merry-go-round. You'd expect the horses on the outside to move slower than the ones near the center, right? It's just basic physics. But Rubin found that the stars way out on the very edge of galaxies were moving just as fast as the ones near the middle. The only way that makes any sense is if the entire galaxy is sitting inside a giant invisible halo of matter. So, for decades, this was really compelling stuff. But some scientists pushed back. They said, hey, maybe we just don't understand gravity on these huge cosmic scales. I mean, it's a fair question. To prove dark matter was a real physical thing, we needed a smoking gun, irrefutable proof that showed dark matter acting on its own, completely separate from normal matter.
And we found that smoking gun right here, in the wreckage of a colossal cosmic car crash. This is the Bullet Cluster. It's what's left after two massive galaxy clusters smashed into each other at millions of miles an hour. And this collision, it gave us the perfect natural experiment to see how different kinds of matter act under pressure. Okay, let's break down what happened here. Most of the normal matter in these clusters is actually superheated gas. So when the clusters hit each other, all that gas just slammed together and slowed way down, creating that glowing shockwave you see right in the middle. But the individual galaxies, they're mostly empty space, so they just passed right through each other like ghosts. So the big question is, where did all the gravity go?
And here's the crucial part. Using a technique called gravitational lensing, which is just mapping how mass bends light, we can see where all the gravity actually is. And the answer is crystal clear. The gravity is not with the normal matter, that hot gas in the middle. Nope, it passed right through the collision, staying with the galaxies. This was it. This proved that most of the mass in the universe is some other, invisible, collisionless stuff. This was the smoking gun.
Okay, so we've established that our culprit exists. It's real, it's out there, and it's massive. So now it's time to do a little criminal profiling and look at the suspect lineup. What could this stuff actually be? So who are the prime suspects in this cosmic case? The answer is probably something totally new, something that goes beyond our current understanding of particle physics. And there are a few really interesting candidates. For a long time, the leading suspects were these things called WIMPs, weakly interacting massive particles.
They were the perfect candidate, theoretically. But here's the thing. After decades of looking, we found nothing. That's opened the door for other ideas, like axions, which are these incredibly light particles, almost like ghosts. Then you've got even wilder ideas like sterile neutrinos or even primordial black holes that might have formed in the first seconds after the Big Bang.
All right, we have a crime scene. We have clues. We have a list of suspects. Now we launch the manhunt. And I mean a massive global effort using some of the most advanced technology humanity has ever built to finally catch a dark matter particle and unmask this cosmic ghost.
The search is happening on three main fronts. First, there's direct detection. Scientists build these super sensitive detectors deep underground, shielded from all the cosmic noise. And they just wait. They wait for the tiny ping of a dark matter particle bumping into one of their atoms. Second is indirect detection. That's where we use telescopes to look for flashes of energy, like gamma rays, that might be created when two dark matter particles smash into each other out in space. And finally, we're trying to make this stuff ourselves by smashing particles together at the Large Hadron Collider to see if we can get dark matter to pop out of the explosion.
So, with all of this incredible effort, all of these brilliant people, after decades of searching, how many dark matter particles have we actually found? 0. A big, fat 0. It is one of the biggest and most frustrating null results in the history of science. The universe's biggest secret is still a secret.
But listen, a null result doesn't mean we failed. Not at all. In fact, it's pushing physics into some really fascinating new places. Our detectors are now so ridiculously sensitive that they're running into a brand new problem, something called the neutrino fog. They're starting to pick up faint signals from neutrinos streaming from the sun and space. And this cosmic background noise could be hiding or even faking a real dark matter signal. We are getting that close.
So, where does that leave our investigation? We know something's out there. We've got its fingerprints all over the cosmos. We have a lineup of suspects, a global dragnet out looking for them. We are right on the edge of discovery, facing this one final huge question. Are we about to finally unmask the ghost that built the entire universe? Or are we just beginning to realize how deep the darkness really goes?